All right, in this video, I'm going to be continuing my process of explaining why I believe that someone used this geometric pattern in the past to come up with the various designs of the numerals. And in this video specifically, we're going to talk about the numeral that's called dec. So that represents what we would call the number 10 in base 10, but in base 12, it's called dec. You can remember that word because it's connected to the word decade, so D-E-C, dec. It's the length of 10. So we're going to go to the corresponding circle in this series that has the radius of the square root of dec, or the square root of 10. So we find the positions of the points that define that circle by traveling along the x-axis, the length of 3, or the square root of 9. Then we do a right angle, and we go to that point there, and we do that on all four directions, and we get 8 points that define the length of the square root of 10, but in base 12 we're calling it dec. So the first impulse that I had when I was trying to figure out how they came up with the various numerals, because we know that the symbol has an X in it, I thought, well, we're just going to connect these points like that, go right across from here to there, and my pen's drying up, that's okay, and from here to there, and now we've got a symbol that looks like an X, you can see it there, and it's connected to some of the points that define that shape. But the problem with that is that it's not actually looking like it's supposed to. We have these tails, or these little extra bits on one side of that symbol that aren't present here, and we don't have the length of 10 or dec incorporated into the symbol. The height is too much, these lines don't add up. So this isn't how they did it, but it's a start. So what I need to do now is introduce you to another geometric pattern that most people aren't aware of. If you've bought my book, you will be aware of it, but if you probably haven't. So what I'm going to do is I'm going to flip my board around, and I'm going to introduce you to a geometric pattern that's also anchored on the base 12 Cartesian plane. Just going to line that up as best I can. There we go. So you can see these lines radiating out from the center here. They all have the slope of going over 1 and up 0.7, over 1, up 0.7, or up 1, over 0.7, up 1, over 0.7. So remember, those are 0.7 in base 12, so it's a smaller unit than 0.7 in base 10. Remember, the base 12 Cartesian plane, these 1 by 1 squares are divided into 12ths instead of 10ths. So there's 12 little squares inside there. The length of 0.1 is smaller. So in the next video, I'm going to show you a little bit more about this geometric pattern and explain how someone was using it